Welcome to the third episode of our Assault on Batteries. In this episode, we investigate a new chemistry and review our latest test results. But first, a report of a setback. In our previous episode, we were excited to announce this bang-for-the-buck analysis of disposable cells. By combining our test results with retail prices, we captured the state of the market in terms of dollars per watt-hour, given the number of cells in a package. Unfortunately, this portion of our website has to be turned off until we can automatically access pricing information. Here's what happened. Our original plan was to manually update the pricing until the process could be automated. To get access to Amazon's API, we had to apply to their Associates program and drive 3 qualifying orders within 180 days, which thanks to you we achieved in short order. But then we received an email telling us our application does not qualify and our account was closed. It claimed the link we provided was invalid or non-existent. After a failed appeal, we now believe, but are by no means certain, our mistake was giving them the link of the main site, not of the specific pages with these affiliate links. Easily fixed if we reapplied, except during the appeal, we learned Amazon does not want us manually updating these prices. In other words, we can't provide a price comparison until we're an Amazon associate, and we can't be an associate if we compare prices. That's some catch, that catch-22. Frustrated, we reconsidered our approach. We never were comfortable partnering with a multinational corporation. Affiliate commissions won't pay for much lab time, and we wondered if they compromised our neutrality. Why not just scrape the data from their website? Well, it turns out web scraping has ethical issues, and especially in the US, legal liabilities. Follow the link in the description to learn more about the case law. We're wiser now, and grateful Amazon offers an API at all, but we're not sure how we're going to get pricing from other retailers like Walmart and Costco. Walmart also has an API, but it appears to be just for their marketplace sellers. Despite these snags, we still think our analysis has potential. We'll provide a link in the description to the current best deal for a package of 12 cells. If you'd like to help, all you have to do is follow the link and buy something. You don't even have to buy what we recommend, just buy something in the same browser session. Once we have access to Amazon's API, we'll switch that portion of the website on again. Meanwhile, you can still use our scoreboard to do your own analysis by dividing the cost of the cell by the energy it stores. For example, the reigning champ, Costco's Kirkland cell, is currently $15.99 for 48 cells, which works out to 40 cents per watt hour. And if you know how to access prices without violating a retailer's terms of service, please let us know in a comment. Amazon.com has been selling rechargeable nickel-zinc cells from EBL and CLDP since 2023. With the help of our patrons, we purchased and tested samples. The EBL cells discharge an average of 1.4 watt-hours, which is competitive with nickel metal hydride. These cells boast a low internal resistance and a 1.65 volt nominal output. Sure enough, fully charged, all our samples had open circuit voltages above 1.8 volts. Will the extra voltage damage your devices? Probably not flashlights and motorized devices, but check your user manual before using them in electronics. Their cutoff voltage is also higher. EBL told us discharging nickel-zinc cells below 1.2 volts can potentially damage the cells. That's not ideal. In a device that's designed for alkaline chemistry, it's too easy to unknowingly discharge cells below cutoff. Take, for example, our old Apple trackpad. With both its cells at 1.2 volts, it reports a battery level of 23%. By the time a low battery notice appears on the desktop, cell voltage is well below the recommended cutoff for nickel-zinc. We wondered if this explained complaints on Amazon about nickel-zinc cycle life, so we charged and discharged our samples 12 times. Like nickel metal hydride, they actually stored more energy after a break-in period, except for this outlier. According to Wikipedia, their self-discharge rate increases after 30 to 50 cycles. But even so, they are still far less expensive per watt-hour than disposable cells. They can be used in situations where discharge can be anticipated, like in wireless door locks. This also applies to other chemistries. For example, you can save a lot of money replacing disposable lithium manganese dioxide cells with rechargeable lithium iron phosphate if you characterize your device's power consumption and recharge frequently enough to avoid discharge below cutoff. We were curious how well nickel-zinc chemistry performs at different temperatures, but EBL couldn't give us a datasheet, so we tested them at 41 degrees C, or 20 degrees above normal. They discharged significantly more energy at high temperature. Notice how the outlier was able to join its siblings, but then reverted after it cooled down. This is why it's important to control ambient temperature. CLDP's cells had about half the energy of EBL's, and the strangest discharge curves we've seen in all our testing. If you can imagine a chemical process that produces these wiggles, please share in the comments below. We also ran 12 discharge tests and 1 high temperature test. Unfortunately, heat didn't shrink its error bars. One thing we liked about CLDP is their cells were date stamped, something only a handful of offshore manufacturers do. We also like datasheets and lot numbers. Without a datasheet, you don't know what to expect and have no grounds on which to complain if the cells don't perform. Lot numbers allow manufacturers to investigate high batch failure rates and at least suggest they take quality control seriously. One of our viewers noticed PowerOwl's advertising on Amazon. Their disposable lithium cells did quite well in terms of bang for the buck. As we record, you can get a 12-pack for 83 cents per watt hour, which is 16% cheaper than Energizer's Ultimate Lithium. Their rechargeable lithium-ion EC5200 didn't fare as well on the scoreboard with only 1.95 watt-hours. It broke X-Star's EMI record with a peak above 78 dB microvolts, but was unusually quiet above a load of 600 milliamps. We'll also provide an affiliate link to this Lenink battery replacement adapter. Parts of this gadget allowed us to power our trackpad with a lab power supply. We were impressed that it's as quiet as the EMI gold standard, the Apple A1385. Thanks for watching. You know what to do if you like this video. Comments and suggestions are welcome below. Our Assault on Battery scoreboard is published for all to see at the link in the description below. We're an independent test lab, not sponsored or influenced by manufacturers. For online access to all the web pages shown in this video, as well as future test results, please consider supporting us on Patreon.